Hello friends, welcome to our channel where we are presenting lessons in mathematics. Okay, so in this presentation, in this video, we want to deal with the introductory part to geometrical transformation. Geometrical transformations. All right. Okay, we want to understand what geometrical transformation is and deal with one type of geometrical transformation. Okay, so now what do we mean when we talk about geometrical transformation? We are saying when you are dealing with geometrical transformation, all right, we are saying it is an operation which maps, by mapping we mean shifting, all right, which maps or shifts a geometric shape from one position to another, all right, following certain rules. In most cases, when we are talking about a transformation, there is a change in size, there is change in position, all right. So you shift an object onto an image. You move it from one point to another point. Okay. You shift it from one point to another point. That's what we mean by geometrical transformation. All right? That's what we mean by geometrical transformation. Okay. So I hope the definition is okay. I hope we are okay with the definition. Okay. So all right. Okay, so we can also look at this definition. All right, in this book. What are they saying? We are saying geometric transformation is a process in which an object, such as a polygon, line, or point, is moved or shifted or changed from its original position, state, or attributes to another or to the other. All right? So by geometrical transformation, we are talking about the shifting of a geometric shape from one position to another. That might also result into a change in size. All right? Now, here we are talking about shape. Now, we can be able to define what a shape is. All right? All right, so there are these other terms that we need to define, we need to understand. Okay. We need to understand what an object is as well as an image. So we are saying, when we talk about an object here, we talk about the original shape. All right? The original shape. When we talk about an image, we're talking about the transformed shape. The shape that has been transformed. So, for example, if you have got a triangle here, A, B, C, then you produce another triangle here, which is A1, B1, and C1. So this shape is the object. Then this one is the image, right? So if this is produced from this one, so this is called the object and this is the image. All right, so you need to be comfortable with these two terms. Okay, and usually to denote an image, we might say maybe A1, maybe A2, A3, just to differentiate one shape from another shape. All right. Besides this, we can also use maybe A prime. All right. Others would go For A prime, maybe I've got A double prime, so on and so forth. These are just notations meant to differentiate one shape from another shape. So you should be comfortable with those notations. Okay. Now, we are saying in mathematics, a shape. What is a shape? All right? Or geometrically, or as you are talking from geometrical transformation point of view or perspective, we are saying a shape is defined as the set of points that defines an object. All right? So if I'm talking about this shape ABC, I'm just talking about these points that define the object. That's what we mean by a shape in this case. All right. Now, the next thing that we need to look at is what we call types or forms of transformation. So basically, we have got 6 types that we need to look at or deal with. The first one is translation. We'll go to refraction, rotation, enlargement, stretch, and shear. All right? The 6 of them. Here we are saying note. When we are done with all these 6 transformations, we need to deal with what we call combined transformations. Because this is what is expected of you in an exam. For example, if you look at this past paper from 2020 internal, this is the question that was there. When you look at this represents what we call combined transformation. So when we are done with all those 6 individually, then we'll look at combined transformation, which is expected of you in an exam. Okay? So now, let's begin dealing with these transformations one by one. All right? And to kickstart, we shall deal with a translation. What is to translate an object? To translate an object simply means you're going to move an object from one position to another position in a straight line. All right? So we are saying this is a transformation which moves an object in a straight line to a new position. So take note that when you're dealing with the translation, all right? When you're dealing with the translation, what is it that you need to know? There's change in position. This is very key. All right? There is change in what? Position. The dimensions of the object remain the same. All right? Dimensions of an object remain the same. All right? But there's change in position. That's what we are saying here. Now, so we are saying translation is usually denoted by T. Of course, we can use any other notation, but in most cases we use T to denote translation. Okay, so you might have an object here called triangle ABC. If this is moved onto another or to a new position, which is maybe A1, B1, and C1. For you to tell that this is a translation, one, you must acknowledge or you must see that there's change in position, all right, and that the size of the object or the size of the object and the image should be the same, right? They should be the same, but there exists a change in position. Okay, so there must be change in position. So now, how do you find the image of a translation? We are saying the image of a translation is given by this. We are saying image is equal to object plus translation vector. So this TV, we are saying it is translation vector. Take note. Translation vector. Others would prefer calling it column vector. Alright? It's one and the same. So this is the translation vector. So you're going to say image is equal to object plus translation vector. Alright? Okay. So that's what we are talking about here. So now, what is it that you need to know for you to describe a translation fully? For you to describe a translation fully, you must acknowledge that it is a translation. Alright? Then 2, give the translation vector. Give the translation vector. Then it's done. Okay? So let's look at an example. We are saying using a scale of 1 centimeter to represent 1 unit on each axis. Draw the x-axis and y-axis for -8 is less or equal to x up to 10, -8 all the way up to 10. Okay? You draw triangle P with these vertices. That is the first one. Okay? So you need to get a graph paper like this one. So what we are saying is that each box, when you measure it, each box can check here. This is 2, 4, 6. So each box is 2 centimeters. But we are saying 1 centimeter to 1 centimeter to represent 1 unit, right, on each axis. And that for the x-axis, you need to have, for the x-axis, you need to have 8 numbers to your left and 10 numbers to your right. So how are you supposed to demarcate your graph paper? You are going to say 1, 2, 3, 4, 5 here, because here you have 2, 4, 6, 8, 10. So you do that. Of course, you need to use a pencil. Right? Then the y-axis, it's again from -8 to 10. So we can just say 1, 2, 3, 4, 5, 6, 7. That one will suffice. Okay. This one will suffice. Alright? So we are saying it is 1 centimeter to 1 unit, meaning that this is 2, this one should be 4, this one 6, 8, you go up to 10. So this is -2, -4, -6, -8. So you have got 2, 4, 6, 8, 10. Alright? -2, -4, -6, -8. Okay. So we are saying 1 centimeter to 1 unit, meaning that half of this, when you check here, so this is where 1 is. So this should be 1 unit. You can even count the number of boxes. So this here you have 1, 2, 3, 4, 5, 6, 7. Alright, 8, 9 here. Okay, even this side. Now this point, this point, this point, this point, and that point. So you have -1, -2, -3, -4, -5, 6, -7. Right? 1, 2, 3, 4, 5. This is 1. 1, 2, 3, 4, 5. This is 3. 1, 2, 3, 4, 5. This is the 5. 1, 2, 3, 4, 5. This is the 7. 1, 2, 3, 4, 5. This is the 9. Okay, you need to write them properly. 1, 2, 3, 4, 5. Negative 1. 1, 2, 3, 4, 5. This is negative 3. 1, 2, 3, 4, 5. This is negative 5. 1, 2, 3, 4, 5. This is negative 7. Right. So now we begin to do what they have been asked to do. So the first thing is we draw triangle P with these vertices. The first one is 2, 4. So go to x-axis. X is 2. All right. 2, 4. Here is where our A is. Then B 1, 2. 1, 2 here. This is where your B is. C 3, 1. 3, 1 is this one. Alright, so this is your B and this is your C. So you join. Okay, so this is the first one. All right, so that is the first one. So you can say A for A, that is the, and then this should be triangle P. You say this is triangle P. Okay, then we go to the second question, B1. Find the coordinates of the image of triangle P when it is translated by translation vector T, which is 4, 1. Take note, this is X and this is Y. Alright? So if we were to find the coordinates of the image, alright? So to find the coordinates of the image, like I was saying, you can go direct or use the formula. You use this formula. Okay, image is got object plus translation vector. So now, let's use the two methods where we go direct. We are saying x is 4, y is 1, meaning that 4 steps to the right and 1 step back upwards. Okay, so we are going to say from here, each point, we are going to say from here, you have 1, 2, 3 here, 4. 4 will take you to here, 7. Okay? So this is where your C1 will be here. There will be C1 here. Alright? C1. Take note. Then you go to, what I've said, 1. Take note here. This is not C1. We are saying 1, 2, 3, 4, but 1 step upwards, all right, because of this. Okay, so from here you're going to say, okay, I'm at 2, I should go to 3. 1, 2, 3, 4, 5. So this is where our C1 should be here. So you have got C1 here. All right, take note, this is not needed. Then this is not needed. Then we go to this point A. So here you have got 2, because you have got 1, 2, all right, 3, 4. Again, you move 1 step upwards. You're going to say 1, 2, 3, 4, 5, because that is 1. So you have got this one. This is your A1. Okay? Your B1 against the same. 1, 2, 3, 4 here. 1 step upwards. So one step upwards will take us to 3. So we say 1, 2, 3, 4, 5. This is where we are. This is B1. Then you join. So you can go straight. Okay, so here, where we are saying find the coordinates, we know that A1, what is A1? A1 is negative 6, 5. 6, 5. All right? What is B1? We can check B1 here. B1 is 5,3. 5,3. Then C1, what is C1? C1 is 7,3. 7,3. This is what we are talking about. Okay? 7,3. Okay. Now, we can get the same coordinates using a different method. You're saying image is equal to object plus translation vector. By translation vector, we mean by what size are you going to move the object. So we'll say, okay, we want to find the image of what? A1. So say A1 is equal to, what are the coordinates for A? 2, 4, plus, what is our translation vector? 4, 1. When we add this, what do we get? This is 6 and this is 5. Alright? Which is this one. Okay? Which is this one. Then you just go and the plot here, you say 6, 5. You go to 6, 5. That is your point. Alright? If you go to B1, it's the same. What is our B? 1, 2 plus 4, 1. Alright? Here, what we get? 5. Here we get 3. Alright? Meaning that it is the 3, 5, which is what we got here. And you go and plot. You do the same to C. Alright? So for B Roman numeral 1. So we have A1. Okay, I hope it's clear now. A1 is 6, 5. B1, you have 5, 3. C1, you have 7, 3. Those are the coordinates of P. All right? Of P image. So here, Roman numeral 2, where we are asked to draw, we are going to say this is triangle P1, the one that we have drawn. So we'll call this P1. Okay, that is P1. I hope that is okay. Let's go to C. C, we are saying find the column vector which maps triangle P onto P2, right? With vertices. So if you want, you can draw P2. What are the vertices for P2? Vertices A2 is 7, 10. All right? You go to 7, 10. 7, 10. This is 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is it. A2. 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 The next one is B2, 6, 8. 6 here, 8 here. This is the B2. The next one is C2, 8, 7. 8. 8 comma 8,7. Okay, let's check this point first. Okay, so this is the 8,8. Take note. So that is 8,8, not 7. I just checked here. So it's supposed to be 8,8 somewhere here. So we have C2. Then get your ruler and join. Okay, so this is our C. Okay, that is our C. So you are going to say C here, you write your C here. So we are saying find the column vector which maps P onto P2. This is P2, right? Okay, so what is the column vector? You can just use one point. You can even use the formula. All right, but by just seeing, you can tell that when you look at A and its image, or B and its image here, from B, how many steps have we taken? 1, 2, 3, 4, 5. All right, 5. So the translation vector there with regard to x is 5. So we are saying 1, 2, 3, 4, 5. Then we move not until we find this point. 1, 2, 3, 4, 5, 6. All right? Take note. 1, 2, 3, 4, 5. I found this one, so it's 5 here. So I'll say 1, 2, 3, 4, 5, 6. So 6, and this is the translation vector. You can check this one, A. We've got 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5, 6. It's the same. Okay? Alternatively, you can use the formula and say image is equal to object plus translation vector. So you can use maybe A and its image. All right? When you look at the coordinates for A, they are 2, 4. So I've got 2, 4. Okay. Sorry, this is the, take note. Let me just try to use a pen paper. So we can even use this formula. Image is equal to object plus translation vector. Then pick one of the points. Maybe A and its image, B and its image. By A, if you pick on A, you have 2, 4. Its image here is 7, 10. So by this, we are saying what is the image? 7, 10 is equal to what is the object? 2. You have 2 and 4 here. All right, we should get the translation vector. So we say 7, 10 minus 2, 4. The answer is the translation vector. This minus that, you get 5. This minus that, you get 6. So our translation vector is 6, 5,6, which is this one, 5,6. You can get direct or use this formula. I hope that is okay. Okay, let's go to D. D. Triangle P is mapped onto triangle P3 with these vertices, -3, 7. So okay, you can even draw it. -3, -3, 7. Okay, so here we need to have 5. So this triangle is mapped onto another triangle P3. with these vertices. So if you draw this, you have got this one. Negative 3,7, negative 3,7, negative 4,5, negative 4,5, negative 2,5, negative 2,5. This is the triangle they are talking about. Now what is the question? Okay. The question is, draw this triangle which we have drawn already. So this was D. So D1 triangle P3. Alright? How about the second one? We are asked to describe fully the transformation. Fully a single transformation which maps triangle P, right? Which maps triangle P onto triangle P3. So we have got this triangle onto this one. So one thing that we are able to observe is that there has been a change of position from this position to another position. The dimensions are the same. It means this is the translation. So we are going to say it is the translation. Okay? Then you must give a translation vector. So a translation vector is equal to, when you look at B and its image, how many times have we moved to point B? 1, 2, 3, 4, 5. 5. And we are moving to the negative. So it's negative 5. Okay? Then how many times have we moved from here to there? So this is 1, 2, 3, upwards. So this is the translation vector. And that's how you are going to describe that. That's where we end for this presentation. Thank you so much, but I'll be able to give you an exercise. Okay, you can try this exercise. Try to copy it. Okay, thank you so much.